This is probably the easiest section in terms of materials, but since push is always such a hassle, it could possibly take you the most to complete. I chose to use push for all the server originating communications, which has its drawbacks. A better strategy might have been a combination of push and WebSockets, but in the interest of brevity I chose to go with push alone as I demonstrated WebSockets enough and will go back to them in the future. Push notification allows us to send notification to a device while the application might be in the background. This is important both as a marketing tool and as a basic communications service. Polling the server seems like a sensible, time-proven strategy. However, there are many complexities related to that approach in mobile phones. The biggest problem is that polling application will be killed by the OS as it is sent to the background to conserve OS resources. While this might work in some OSs and some cases, this isn't something you can rely on. For instance, Android 6 Plus tightened the background process behavior significantly. The other issue is battery life. New OSs expose battery wasting applications and as a result might trigger uninstalls. This makes even foreground polling less appealing. If you are new to mobile development, then you heard a lot of the buzzwords and very little substance. The problem is that iOS and Android have very different ideas of what push is and should be. For Android, push is a communication system that the server can initiate. For instance, the cloud can send any packet of data and the device can process it in rather elaborate ways. For iOS, push is mostly a visual notification triggered by the server to draw attention to new information inside an app. These don't sound very different until you realize that in Android you can receive/process a push without the awareness of the end user. In iOS, a push notification is displayed to the user, but the app might be unaware of it. This is important. iOS will only deliver the push notification to the app if it is running or if the user clicked the push notification pop-up. Codename 1 tries to make both OSs feel similar, so background push calls act the same in iOS and Android as a result. You shouldn't push important data. Push is lossy and shouldn't include a payload that must arrive. Instead, use push as a flag to indicate that the server has additional data for the app to fetch. For this case, we use push to let the app know about an update. It then performs a refresh to fetch the actual data with the usual web services. Before we proceed, I think it's a good time to discuss the various types of push messages. 0 or 1 is the default push type. They work everywhere and present the string as the push alert to the user. 2 is hidden, non-visual push. This won't show any visual indicator on any OS. In Android, this will trigger the push string call with the message body. In iOS, this will only happen if the application is in the foreground, otherwise the push will be lost. 3 allows combining a visual push with a non-visual portion. Expects a message in the form of "this is what the user won't see," semicolon, "this is something he will see." For instance, you can bundle a special ID or even a JSON string in the hidden part while including a friendly message in the visual part. When active, this will trigger the push string method twice, once with the visual and once with the hidden data. Notice that if the push arrives when the app is in the background on iOS and the user doesn't tap the notification, neither one of the messages will be received by the app. 4 allows splitting the visual push request based on the format title, semicolon body to provide better visual representation in some OSs. 5 sends a regular push message but doesn't play a sound when the push arrives. 100 sets a number badge. It's applicable only to iOS. It allows setting a numeric badge on the icon to the given number. The body of the message must be a number, for instance, unread count. 101 is identical to 100 with an added message payload separated with a space. For instance, 30 space, you have 30 unread messages. We'll set the badge to 30 and present the push notification text. You have 30 unread messages. This again is iOS only. We need some values from Google and Apple to fill FB clone keys properties. These values help us send the push through the Apple/Google servers. We need the following keys in that properties file. Notice I will go into the process of obtaining each of those soon. Push.iTunes production is true or false. iOS push calls target either the production or the development servers. Push iTunes prod cert. Don't confuse this with a certificate used for app signing. This is a separate certificate used for authenticating against Apple's push servers. You need to host it in the cloud. We do that for you if you use the certificate wizard. Push.iTunes prod pass. This is the password for Push iTunes prod cert certificate. Push iTunes dev cert. Just like with the code signing, we have two certificates. So this one is used when we are pushing in the sandbox during development. This is used when push iTunes production is set to false. Push iTunes dev pass. This is the password for the Push iTunes Dev Cert certificate. Push token. This is a secure token you can fetch from your Codename1 account in the Settings tab. Push.gcm key. This is the value you need to fetch from Google Developer Tools console. Android push goes through Google servers, and to do that, we need to register with Google to get keys for the server usage. You need one important value, push.gcm key. To generate this value, follow these steps. Log in to console.cloud.google.com. Select APIs and services. Select library. Select developer tools. Select Google Cloud Messaging. Click Enable and follow the instructions. The value we need is the API key, which you can see under the Credentials entry. You will need to rerun the certificate wizard for the project for iOS. If you generated certificates before, say no to the step that asks you to revoke them, and copy your existing credentials, certificate, P12 file, and password to the new project. Make sure to check the include push flag in the wizard so the generated provisioning includes push data. Once this is done, you should receive an email that includes the certificate details. This will include URLs for the push certificate we generated for you and the passwords for those certificates. Apple has two push servers, Sandbox, use this during development, Production. This will only work for shipping apps. You need to toggle the push.iTunes production flag so push messages go to the production version of the app. Now that we understood the theory, let's go into the practical terms of sending push notifications from the server. The first step is in the user entity. We need to access the device push key so we can send a push message to the user's device. That's it. Well, almost. There are also getters and setters, but I always ignore those anyway. This isn't in the DAO, so there is no boilerplate there. The push key is private to the server. It has no place in the DAO, so we leave it here. We do, however, need to add a method to the user repository interface. We need this finder to remove out-of-date and expired push keys based on messages sent from the push server. We need to expose the properties that we added to the FB clone keys properties file in the notification service bean. My first intuition was to inject the user service into the notification service class. This failed. The reason it failed is circular references. User service already references notification service, so including user service there would mean Spring Boot would need to create user service, create notification service to inject into user service, create a user service to inject into the notification service, etc. Thankfully, it fails quickly with an error. The solution itself is pretty simple though. We add a new service that will handle this, API keys. We removed this code from user service as is and placed it here. These two helper methods remove the need to use API keys variables directly. The next step is injecting this into both user service and notification service. I'll demonstrate this in the notification service, but the change to user service is the same. I'll get to the surrounding methods soon, but for now I just wanted to show how to use this new API to get the values from the properties file. So all we need to do is replace every call to prop.getProperty with keys.get. That's also far more flexible and elegant. In the future, we can probably use a smarter system for configuration than a properties file, now that it's encapsulated.